Alright guys, we just have a few more shapes to go over here, and then we are done learning new content for the year. Awesome, right? So we learned about a bunch of different shapes yesterday, so I wanted to just go over a few more today, ones you're probably familiar with, but maybe haven't thought about volume, and just show you kind of how you might work through that. So I want to talk first thing about cone. So a cone, kind of like an ice cream cone, is like a pyramid. It's not technically a pyramid, but it's like a pyramid, but it has a circular base. So it's closely related to the pyramid in terms of its formula for its volume. So its formula for its volume is going to be 1/3 pi r squared h. And you might recognize that pi r squared is really just the area of a circle. So you could also think about it as the volume equals 1/3 times the base, area of the base, times the height, area of base. Okay? So pretty simple, kind of, again, pretty similar to the pyramid formula as well. And it makes sense, right? It's pretty similar shape. So we'll run through a couple quick examples. You'll need your calculators if you don't have them. So first one, volume of the oblique cone. So it's not a right cone, but it's an oblique cone. So to find the volume, this one's pretty simple. It gives us the height, so it would just be 1/3, right, times the area of the base, which is pi, times 2.2 squared, times the height, which is 4.5. That's going to be all equal to, we round maybe to 2 decimals, 2.81 centimeters cubed. Okay. Number 2, give it a shot on your own. You're going to have to use some trig. Okay, you're going to have to use some trig. So give you a second, hit pause, see if you can figure out. Round your final volume, let's say, to 2 decimals, and then let me know what you get. All right, so hopefully you've done that. So we need to find, right, the radius. So if I'm looking at this triangle here, right, this guy, let me use a different color, right, that triangle right there. I need to find the radius. I have the adjacent, or I have a leg, opposite leg of 65 degrees, and I want to find the adjacent leg. So I could easily find it by doing tangent of 65 equals 16 over r, and if you solve for r is 7.46 centimeters. So now to find the volume, right, it's 1/3 pi times 7.46 squared times 16, and our volume is approximately 932.45 centimeters cubed. All right, so volume of a cone, pretty simple. Number 3, it says you're using the funnel shown to measure the coarseness of a particular type of sand. It takes 2.8 seconds for the sand to empty out of the funnel. Find the flow rate of the sand in milliliters per second. It's basically saying how much sand is flowing out per second, right? So again, I encourage you maybe to pause the video, see if you can take a shot at that, and then see if your answers match mine. Okay, so hopefully you got an answer. We want to know how fast it's flowing out per second. We know how many seconds it takes to flow out, so we got to know how big or what the volume of the sand is. So that would be pretty simple in this case. The volume is going to equal 1/3 times pi times 4 squared times the height, which is 100.53 cms cubed. That's the volume of the sand in the cylinder, or excuse me, the cylinder in the cone. So if we want to know the flow rate, we're going to do 100.53 over 2.8, and we get 35.90 milliliters per second. So hopefully you got the same thing. All right, guys, last thing. Spheres, I'm sure you know what a sphere is, right? It's kind of like someone said a couple years ago, a 3D circle. It's not quite, but it's the same idea, right? Okay, so like a circle, if you remember the definition of a circle, was a set of all points equidistant from a point. A sphere is a set of all points equidistant from another point too. So you might say, well, how does it differ? Well, however, unlike a circle, is a sphere is a set of points in a 3-dimensional space. So when we talk about circles, we're only talking about all the points in a two-dimensional space. When we talk about spheres, we're talking about all the points in a three-dimensional space. And the volume of a sphere is just given by 4/3 pi r cubed, right? R cubed is a three-dimensional space, so we need to be cubing it. All right, so a couple quick examples, and then that'll be it. So what is the volume of a ball with the diameter of 9? Well, if the diameter is 9, we know the radius is 4.5. So it's as simple as doing volume 4/3 pi times 4.5 cubed. Do that out, round to 2 decimals, 381.7. Doesn't give us units, so we'll just say units cubed. So we got 2a, 2b. Find the volume to the nearest centimeter of a sphere in a cube with edges 6 centimeters long. All right, so let's see how good of an artist I am here. So we have a cube 6 centimeters long. So I'm going to draw my best attempt at cube. Let's see how I do. Right, so we've got that in the back. And then inside, if I can draw this, right, we've got a cube that's touching all the sides. So if that's the case, and there's my radius that's touching one of the sides, the radius should be half the length of an edge, so it should be 3. So my r of my cube should be 3. So the volume of that sphere should be 4/3 pi times the radius cubed, which comes out to 113.10 centimeters cubed. And then the last one, find the volume of the region inside the cube, but outside the sphere. So really it's just going to be the difference. We did a couple of these with the area ones, similar to that. We're going to need to subtract the two. So to do that, we need to find the volume of the cube. So the volume of the cube, as you remember from yesterday, would be each side squared, or cubed. So 216 centimeters cubed. So the volume outside would be the difference between them. So 216 minus 113.10, and I get 102.90 centimeters cubed. All right, so that's it for spheres and cones. Not too much going on here. I just wanted you to see them so you have an idea of how you might calculate those, but we're not going to get too deep into them. Probably tackle too many really difficult problems with them, but now you know what they are. The homework is from the book. Okay, it's from the book, so let me give it to you. I'll write it, right, let me scroll down below here so we have a little more room to write. So your homework, okay, it's going to go back to yesterday's work too, okay? So your homework, okay, is page 479, numbers 23, 24, and 31. That's going to cover stuff from yesterday. Page 494 to 495, numbers 23 and 33, and then page 500, number 16. So those 6 problems, again, some of them cover the stuff we just did now, some of them cover the stuff from yesterday, and that's going to be it for volume. See you guys tomorrow.